Hello, I'm Tom Science. We will take a closer look at the strange and mysterious objects known as black holes and white holes. These are two of the most intriguing and exotic phenomena in the universe, and their properties and behaviors have fascinated scientists and the general public alike for decades. In the following sections, we will discuss what black holes and white holes are, how they are formed, what they do, and what we can learn from studying them. What are black holes? Imagine you're taking a hike in the mountains and you come across a deep, dark cave. You're curious, so you shine a flashlight into the cave, but you can't see anything because it's so dark. You decide to toss a rock into the cave to see how deep it is, but you don't hear it hit the bottom. It's as if the cave is swallowing up the sound. This is a bit like what happens with a black hole. The event horizon is like the mouth of the cave, and anything that falls in is swallowed up and never seen again. Black holes are regions of space where the gravitational pull is so strong that nothing can escape, not even light. They are formed when a massive star runs out of fuel and collapses in on itself under the force of its own gravity. As it collapses, it creates a singularity, a point of infinite density and zero volume. The region around the singularity is called the event horizon, and anything that crosses it is pulled into the black hole and is lost forever. How are black holes formed? When a massive star runs out of fuel, it can no longer generate the energy needed to counteract the force of its own gravity. As a result, the star begins to shrink and collapse in on itself. This process is known as gravitational collapse, and it is what ultimately leads to the formation of a black hole. The more massive the star, the more powerful its gravitational field, and the greater the chance that it will collapse into a black hole. What happens inside a black hole? Inside a black hole, the laws of physics as we know them break down. Space and time become so distorted that they no longer behave in the way we are used to. Scientists believe that inside a black hole, space and time may actually be reversed, meaning that the future is in the direction of the center of the black hole, and the past is in the direction of the event horizon. It is a region of space where the very fabric of the universe is warped beyond recognition. What happens around a black hole? Black holes are not actually black at all. While no light can escape from a black hole, the regions surrounding the event horizon can be incredibly bright. This is because as matter and energy are pulled into the black hole, they become superheated and emit intense radiation in the form of X-rays and gamma rays. This radiation can be detected by telescopes, and it provides important clues to the nature of black holes and the material that surrounds them. Example of black hole. To better understand the effects of a black hole, let us imagine a spaceship approaching a black hole. As the spaceship gets closer, the gravitational pull becomes stronger, and the crew starts to feel the effects. First, their feet become heavier as they are pulled towards the black hole, then their bodies and heads. Eventually, the gravitational force becomes so strong that the crew is stretched out into a long, thin stream of atoms, called the spaghettification effect. At this point, the spaceship and its crew have crossed the event horizon and are doomed to be pulled into the black hole's singularity. What are white holes? To help visualize what a white hole might be like, let's imagine a magical fountain that shoots water into the air, but nothing can go into it. This fountain is constantly spraying water in all directions, and the water flies up into the sky and then rains back down to the ground. But no matter how hard you try, you can't pour water into the fountain, and any water that touches it is repelled and splashes away. This is kind of what a white hole might be like, a region of space that is constantly emitting matter and energy, but which cannot be entered by anything else. White holes are hypothetical objects that are essentially the opposite of black holes. They repel matter and energy rather than attracting it. In theory, a white hole would emit matter and energy in a continuous stream, but nothing could ever enter it. What is a wormhole? One of the most interesting things about white holes is that they are thought to be connected to black holes through a phenomenon called a wormhole. A wormhole is a tunnel through space-time that connects two points in the universe. It's a bit like a shortcut that allows you to travel great distances. How are white holes formed? White holes are purely theoretical objects and have not yet been observed by astronomers. They are thought to be the result of a mathematical calculation, which is the opposite of how black holes are formed. Instead of a star collapsing in on itself under the force of its own gravity, a white hole would be formed by the expansion of the universe itself. This expansion would create a region of space where matter and energy are repelled, rather than attracted. How do white holes behave? Because white holes are purely theoretical, it is difficult to say for certain how they behave. However, some scientists believe that white holes would emit matter and energy in a continuous stream, similar to a black hole's accretion disk but in reverse. Instead of absorbing matter and energy, a white hole would expel it. This would create a bright, glowing region of space that would be visible from great distances. Example of white hole. To better understand the concept of a white hole, let's imagine a scenario in which a black hole and a white hole are connected by a wormhole. Suppose that a spaceship enters the wormhole at the black hole's event horizon. As the ship passes through the wormhole, it emerges from the white hole and is propelled away at great speeds by the energy emitted by the white hole. This would be a bit like a slingshot effect, where the ship uses the energy of the white hole to accelerate and travel great distances in a short amount of time. Conclusion. In conclusion, black holes and white holes are two of the most intriguing and mysterious phenomena in the universe. Black holes are regions of space where the gravitational pull is so strong that nothing can escape, while white holes are the opposite, regions of space where matter and energy are repelled. While black holes have been observed and studied in great detail, white holes are still purely theoretical objects that have not yet been observed. However, the concept of a wormhole connecting a black hole and a white hole is a fascinating one and raises interesting possibilities for space travel and exploration.